Imagine this. Earth is no longer habitable. Climate disasters, overpopulation, limited resources. Where do we go next? The answer, according to Elon Musk, is clear. Mars. But here's the real question. Can humans actually survive on Mars? Or is this all just science fiction wrapped in optimism? In this video, we're diving into the science, the tech, and the terrifying truth behind colonizing the red planet. Strap in, we're about to leave Earth. Mars is the fourth planet from the Sun. A cold, desert-like world about half the size of Earth, but it's also the most Earth-like planet we've found in the solar system. A day on Mars is 24.6 hours, nearly identical to ours. It has polar ice caps, seasons, and signs of past water flow. And it's only 55 million kilometers away at its closest. That's 6 to 9 months of travel time with current tech. So why not Venus or the Moon? Venus is a literal hellscape, 407 degrees Celsius surface temp and crushing pressure. The Moon has no atmosphere, no protection, and extreme temperature swings. Mars, still dangerous, but survivable, in theory. Chapter 2, The Harsh Reality. Let's break down the brutal truth about living on Mars. Mars's atmosphere is 100 times thinner than Earth's. It's 96% carbon dioxide. That means you can't breathe, you can't grow crops, you can't even stand outside without a suit. NASA's MOXIE experiment in 2021 successfully converted Martian CO2 into oxygen, enough for 10 minutes of breathing. That's progress, but we're still decades away from scaling it up. Mars has no magnetic field. Astronauts would be exposed to 250 millisieverts of radiation per year. That's the limit NASA allows for a full career. Long-term exposure increases risks of cancer, cognitive damage, and reproductive issues. Solutions? Underground habitats, ice or regolith shielding, radiation-blocking suits. The average temperature on Mars is minus 63 degrees Celsius. That's about minus 81 degrees Fahrenheit. At night, it can drop to minus 125 degrees Celsius or minus 193 degrees Fahrenheit, especially near the poles. Only the equator offers mild days around 20 degrees Celsius or 68 degrees Fahrenheit, but just for a few hours. Mars's gravity is 38% of Earth's. Sounds fun, right? But long-term, it causes muscle atrophy, bone density loss, and potential heart complications. Our bodies evolved on Earth, not on Mars. Liquid water doesn't exist on Mars's surface due to low pressure, but underground ice and briny soil hold potential. Future colonies would extract this ice and purify it. Food, hydroponics, algae, genetically modified crops. NASA is already testing space farming on the International Space Station. Chapter 3, How We'd Build a Colony. So how do we survive all this? Let's talk tech. SpaceX and Starship. Elon Musk's Starship is designed to carry 100 people and 100 tons of cargo to Mars. It's reusable, cost-effective, and has already completed orbital test flights. The long-term goal is a fleet of 1,000 Starships delivering supplies for Mars colonization. Martian habitats. Early habitats would be prefabricated domes or inflatable modules. Eventually, we'd 3D print structures using Martian regolith. Robotic builders already exist for this. Energy systems. Mars receives only 43% of Earth's sunlight, so solar panels must be more efficient and dust-resistant. As a backup, nuclear reactors like NASA's Kilopower project could be used. Artificial intelligence and robotics. Mars colonies would heavily rely on autonomous bots for activities like mining ice, building shelters, and repairing systems. Chapter 4, Psychological Challenges. Mars isn't just a physical challenge, it's a mental one. Isolation. Crews will be cut off for years. Communication delay. No real-time calls with Earth. Cabin fever, months of staring at red rock and recycled air. NASA already studies this in isolated Earth missions, like HI-SEAS in Hawaii. Mental health support will include VR therapy, group dynamics training, and even AI companions. Chapter 5, When Can We Go? NASA aims to send astronauts to Mars in the late 2030s via the Artemis and Moon to Mars plans. Elon Musk is more ambitious, hoping to send the first crewed mission by mid-2030s. But realistically, a fully self-sustaining colony on Mars could take until 2050 or beyond. The challenges aren't just technical, they're political, financial, and human. Conclusion. So, can humans survive on Mars? Technically, yes, but it won't be easy. It won't be fast, typically. And if this blew your mind, hit the like button and subscribe to CuriousGen, where science meets imagination.